Permutations and combinations. What is the probability that a two-digit whole number will contain exactly 1, 1, 17, and 90? We're going to learn to find permutations and combinations. We'll talk about what they are in a bit. Factorial, permutation, combination. The factorial of a number is the product, that means multiply, of all the whole numbers from the number down to 1. The factorial of 0 is defined to be 1. Here's what that means. 5 factorial, they write that like that. It means 5 times 4 times 3 times 2 times 1. From that number that it names, 5, down to 1, and you multiply each of those. That is read as 5 factorial. So let's evaluate. 9 factorial literally means we take 9 times 8 times 7 times 6 times 5 times 4, 3, 2, and 1, and we get 362,800. Now, B, how do we do this factorial? I want you to write each out. Now what you should be thinking is, how can I simplify this process? Well, I can reduce 8 times 7. 56 is going to be my answer because I could divide 6 and 6 on top and bottom. I could divide 5 and 5 and reduce all those before I multiply. And that's what they're showing me with their red lines. I showed you with blue. I just like blue better. All right. Multiply the remaining items. 8 times 7 is 56. This right here is what you're going to be using a lot today because one thing will cancel out the other and it'll help you out. So now, we need to figure this one out. We still have to remember our PEMDAs, all right? 9 minus 2 would be 7 factorial over 10 factorial. All right, we subtract within the parentheses. We get that. Now we think, what parts can go away? 10 times 9 times 8. All right. And we get 720. They're showing you how to work these and do these. Later on, you're going to be using them. 10 factorial literally means 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. This one would mean 7 times 6. You can write them all out, cross them out, or you can realize in your head, oh, 5 down will cross out. I'll just do 7 times 6 for an answer of 42. Now, those aren't too hard, but you can always come back and look at them. Remember, PEMDAs, got to go in order. Got to do the parentheses first. 8 minus 2 is 6, so 9 factorial over 6 factorial. Oh, you're going to end up taking 9 times 8 times 7. Write them out, cross them out. And you get your answer of 504. So we've done quite a bit of practice with those. Now we're going to work on permutations. A permutation is an arrangement of the things in a certain order. If no letter can be used more than once, there are 6 permutations of the first 3 letters of the alphabet. So no letter can be used more than once. We could write it ABC, ACB, BAC, BCA, CAB, and CBA. Those are the 6 different ways, the 6 different combinations. All right? How do we figure this out for probability? In the first one, there's 3 choices. Second one, there's 2 choices. The third letter, there's going to be 1 choice. All right? What does that mean? Oh, for this first letter, it could have been A, B, or C. Well, whatever one I use, now this second letter could have only been B or C. There's only two choices there. And then whichever one I use, this final letter, there was only one choice left. So with permutations, it's kind of like a factorial. 3 times 2 times 1, isn't it? There's 3 spots, 3 factorial. That tells me how many options there are, because 3 times 2 times 1 is 6. Oh. The product can be written as 3 times 2 times 1, or 3 factorial, which is 6. So, if no letter can be used more than once, there are 60 permutations of the first 5 letters of the alphabet when 3 can be written at a time. So we can use A, B, C, D, E. But we're only going to fill 3 spots. Okay, so how does this work? Only 3 letters. Now we can use the first 5 letters. So with that first letter, there's how many choices? 5. A, B, C, D. Now we made a choice. So that means for the second letter, there's only 4 choices left. And for the third choice, there's only 3 different letters to choose from. 5 times 4 times 3 is 60. Notice the product can be written as the quotient of factorials. 5 times 4 times 3, or 5 factorial, but we're taking away 2 of the options. There's not there, so we cross those out. The number of permutations of n things taken at R at the time is NPR, National Public Radio. How nice. You do want to write this down so you have it for a little bit later. Notice there's a factorial on top. We do a subtraction thing with a factorial on the bottom. All right. Jim has 6 different books. Find the number of orders in which the 6 books can be arranged on a shelf. There's 6 books. We want to arrange them in a different order. So this would be a prime example of 6 factorial. Okay? Because there's 6 and there's 6 spots. Okay? This is the number of possible things to use. That's what that is. This is the number of spots possible. So 6 factorial over 6 minus 6 factorial. 6 factorial over 0 factorial is 720. That first letter is the number of spots, or excuse me, the number of items you have. The second number is the number of spots available to put those items in. Let's look here. If the shelf has room for only 3 books, how many different ways can the 3 of the 6 books be arranged? Here's where we're going to use those numbers now. We have 6 items, but they can only go into 3 different places. So here's where we're going to write our factorials. 6 factorial, because there's the 6 items. There's 6 items, but there's only 3 places, so we do the subtraction. 6 factorial over 3 factorial. We cross them all out. We end up doing 6 times 5 times 4. Which is 120. 6 choices for the first spot. 5 choices for the second spot. 4 choices for the third spot, and then the other 3 books, I don't know what he does with them. There was no room for them on the shelf. There are 7 soup cans in the pantry. Find the number of orders in which all the soup cans can be arranged on a shelf. They all fit on the shelf. So we can think, I've got 7 things. There's 7 spots. Yay, I can fill this thing out and be silly and do all this. 7 minus 7 is 0 factorial. But if there's 7 things and there's 7 spots, just do 7 factorial. 5,040 different ways to put them on there. Wow, it's a lot of different ways. But now, there's only room for 4 of the cans. So when we look at it, there's 7 things that we want to put in 4 spots. This is when we have to use our subtraction, okay? 7 factorial goes on top because there's 7 things. 7 things for 4 spots. 7 minus 4, 3 factorial. We do the crossing out. Then we do the multiplication of 7 times 6 times 5 times 4 and get 840 different ways. All right? There are 840 permutations. This means that the 7 cans can be arranged in the 4 spaces in 840 ways. A combination now. A combination is a selection of the things in any order. Selection of the things in any order. If no letter is to be used more than once, there is only one combination of the first 3 letters of the alphabet. ABC, ABC, or ACB, BCA, are considered to be the same combination of A, B, and C because the order does not matter. With combinations, there's A and there's B and there's C in all of them. So they're the same. Combination, order does not matter. If no letter is to be used more than once, there are 10 combinations of the first 5 letters of the alphabet when 3 at a time. To see this, let's look at the list of permutations on the next slide. So they wrote them all out. This is when there's 5 letters and we can put them into 3 different spots. When we look at it, anytime there's like A, B, and C, no matter what the order, that's all the same one. So here, watch what they do. Oh, those all have A, B, and C. These 6 permutations, all the same combination of A, B, and C, because order doesn't matter. So in the list of 60 permutations, each combination is repeated 6 times. So there are 10 different combinations. We can have A and B and C, we can have A and B and D, we can have A and B and E, we can have A and D and C, we can have ACE, ADE, DBC, ECB, EDB, EDC. And if you look at all those, each row here has, or each column there, has those same letters just arranged in different ways. So notice what they did. 60 permutations, all right, 6 different ways, so there's 10 combinations. So here we are again. The number of combinations of n things taken at R at a time. So the number of things, the spots we have, R factorial. N factorial, R factorial times, oh my gracious, there's so much there. Watch, it is not as bad as it looks. Mary wants to join a book club that offers a choice of 10 new books each month. If Mary wants to buy 2 books, find the number of different pairs she can buy. So, they can be in any order, so we look at this. There are 10 things. She can buy them 2 at a time. So, our 10 things, 10 factorial. The availability, oh, the 2 factorial goes in front. Then we do 10 minus 2, just like we did before, factorial. So, 2 factorial, 8 factorial, write these out. I can cross out all of those. And I'm left with 10 times 9 divided by 2 times 1, which should be 45. Okay. The number of things we have, the number of spots we have to pick them in. That 10 factorial for the number of things we have. That 2 goes here out by itself. Then we do the things we have and the spots we have, subtracting each other. Write it all out, and we can block it all out. This one is a good one to come back and look at when you're doing these combinations. If Mary wants to buy 7 books, find the number of different sets of 7 books she can buy. Okay? There are 10 book choices that the club offers. There are 7 different books you can buy at a time. So possible books, books chosen at a time. Remember that possible books, 10 factorial. Then, at a time, 7 factorial. Then 10 minus 7 factorial. We write them all out. We cross out what we can get rid of. All right. We have 10 times 9 times 8 divided by 3 times 2 times 1. So we get 120. Okay. Possible books, books chosen at a time. And it shows you right how to put them in. All right. Because it goes in the same way every time. All right. Harry wants to join a DVD club. Those are things that used to hold movies. Now we stream everything. All right. There are 12 new DVDs each month. If Harry wants to buy 4 DVDs, find the number of different sets. So you got to think. 12 possible things. Buying 4 at a time. So the 12 goes on top with the factorial. Then the 4 goes in front with the factorial. Then it's parentheses, 12 minus 4, factorial. And we write it all out. So, notice, we crossed all these out, and then they did a little reducing before they multiplied. They took 4 times 3, that's the same as 12, they reduced it. They could have even done this and done 2 and made that to 5, and we get 495. Focusing on this is important. Possible number of choices you want to have, and you put them in the same way every time. There are 495 combinations. This means that Harry can buy 495 different sets of DVDs. If he wants to buy 11 DVDs out of the 12, well, boy, we're going the wrong way. 12 possible DVDs to buy, 11 that he wants to buy. So 12 factorial on top. Then 11 factorial, the number of he's buying. 12 minus 11, that's 1 factorial. We're going to get 12 different combinations. Because all those numbers cross out. All right. There are 12 combinations. This means that Harry can buy 12 different sets of 11 DVDs. Each time holding out a different DVD makes it for a different set of 11. That's everything we got. Those examples of the combinations will make it easier, and you can put them in at any time.